In a shocking turn of events, a British engineer named Frank Whittle revolutionized aviation by inventing the first practical jet engine, which could generate a staggering 1,000 pounds of thrust, a feat that would change the face of air travel forever. Let's explore history of aviation engineering. But what sparked this innovation, and how did it transform the world of aviation? To understand the significance of Whittle's invention, we must delve into the history of jet engines, from their humble beginnings to their current status as the backbone of modern air travel. The concept of jet propulsion dates back to ancient Greece, where mathematician and engineer Hero of Alexandria described a simple jet engine in the 1st century AD. This early design, powered by steam, was the precursor to the modern jet engines that would eventually dominate the skies. However, it wasn't until the 20th century that the first practical jet engines were developed. In the 1920s, Whittle, a young engineer in the Royal Air Force, became fascinated with the idea of using a turbine to drive a compressor, which would then produce a high-velocity exhaust gas. This innovative design would eventually become the core of modern jet engines. Whittle's early experiments with jet engines were met with skepticism, but he persevered, driven by his conviction that this technology could transform aviation. He spent countless hours studying the work of other pioneers, such as Johannes Winkler, a German engineer who had also been experimenting with jet propulsion. Whittle's dedication paid off in 1930, when he founded Power Jets, a company dedicated to developing his jet engine design. Over the next decade, Whittle and his team encountered numerous challenges, from funding issues to technical setbacks. However, their hard work paid off in 1941, when the first British jet aircraft, the Gloster .2839, took to the skies. The success of the Gloster .2839 marked a significant milestone in the history of jet engines. As World War II raged on, the Allies recognized the potential of jet propulsion and invested heavily in its development. The Germans, too, were working on their own jet engine technology, leading to a thrilling race to create the most advanced jet-powered aircraft. The introduction of the Messerschmitt Me 262, the first operational jet fighter, sent shockwaves through the aviation community. The Me 262's impressive speed and agility made it a formidable opponent, and it played a significant role in the final months of the war. In the aftermath of the war, the development of jet engines continued to accelerate. The introduction of commercial jet airliners in the 1950s revolutionized air travel, making it faster, safer, and more accessible to the masses. The de Havilland Comet, the first commercial jet airliner, was a game-changer, offering a level of comfort and convenience previously unimaginable. Today, jet engines power everything from small business jets to massive commercial airliners, and their impact on global commerce and transportation cannot be overstated. As we look to the future, researchers are exploring new technologies, such as electric and hybrid electric propulsion, which promise to make air travel even more efficient and sustainable. The story of jet engines is a testament to human ingenuity and the power of innovation. From humble beginnings to supersonic flight, the evolution of jet engines has been a wild ride, filled with twists and turns, challenges and breakthroughs. As we continue to push the boundaries of what is possible, we must remember the pioneers who paved the way, like Frank Whittle, and strive to create a future where air travel is faster, cleaner, and more accessible to all. The development of modern jet engines has been a long and arduous process, with numerous challenges and setbacks along the way. However, the perseverance and dedication of pioneers like Whittle have paid off, and today we have a wide range of engines that power everything from small drones to massive commercial airliners. One of the most significant challenges in the development of modern jet engines has been the need to balance power and efficiency. Early jet engines were often powerful but inefficient, and it wasn't until the development of more advanced materials and designs that engineers were able to create engines that were both powerful and efficient. Today, we have engines like the General Electric GE90, which powers the Boeing 777, and is capable of producing over 115,000 pounds of thrust while achieving a fuel efficiency of over 30%. The future of jet engines is likely to be shaped by advances in materials science and computer simulation. Researchers are currently exploring the use of advanced materials, such as carbon fiber and nanomaterials, to create lighter and more efficient engines. Additionally, advances in computer simulation are allowing engineers to design and test engines in a virtual environment, reducing the need for physical prototypes and speeding up the development process. As we look to the future, it's clear that the development of jet engines will continue to play a critical role in shaping the world of aviation. Whether it's the development of more efficient engines, the use of alternative fuels, or the creation of new aircraft designs, the future of jet engines is likely to be exciting and unpredictable. The impact of jet engines on society has been profound, and it's hard to imagine a world without them. From the early days of commercial air travel to the modern era of globalization, jet engines have played a critical role in connecting people and cultures around the world. As we move forward, it's essential that we continue to innovate and push the boundaries of what is possible, creating a future where air travel is faster, cleaner, and more accessible to all. The story of jet engines is a testament to human ingenuity and the power of innovation, and it's a reminder that even the most seemingly impossible challenges can be overcome with determination and perseverance. As we continue to explore the possibilities of jet engine technology, we must also consider the environmental impact of air travel and the need to develop more sustainable solutions for the future. The development of electric and hybrid electric propulsion systems is a promising area of research, and it's likely that these technologies will play a significant role in shaping the future of aviation. Additionally, the use of sustainable fuels, such as biofuels and hydrogen, is becoming increasingly important, and it's essential that we continue to invest in research and development in these areas. In conclusion, the history of jet engines is a fascinating story that highlights the power of human innovation and the importance of perseverance in the face of adversity. From the early experiments of Frank Whittle to the modern marvels of commercial aviation, the development of jet engines has been a wild ride, filled with twists and turns, challenges and breakthroughs. As we look to the future, it's essential that we continue to innovate and push the boundaries of what is possible, creating a future where air travel is faster, cleaner, and more accessible to all.